In this video, we're going to be solving systems of linear equations in two variables, second part, but doing so via using the strategy called elimination. That's what I'm pointing out. Elimination is quite powerful and generalizes much easier than the other ways of solving. The learning objectives are, given a system of linear equations, you'll be able to solve it, this case with elimination, and this also will tie into determining if the solution is unique, dependent, or inconsistent, and justifying why, by essentially trying to solve the system. So let's revisit this example here, where we have the two lines, x plus y is equal to 8, and x minus y is equal to 4. Now, in the previous videos, we've already seen how to solve this via substitution and interpreted what that solution is graphically. But here, I'm going to start pointing out a few other things. So the first thing that I'm noticing here is that we have a plus y and we have a minus y. Wouldn't it be nice if we could just add these two equations together and notice that plus y minus y gives us no more y, 0y, to solve? And so let's just try it. So let's say if we have the first equation, so here I'm going to label this one equation 1 and this one equation 2. And so if I add equation 1 plus equation 2, let's see what happens. So if I have an x plus a y is equal to 8, so that's our equation 1, and we're going to add it to the x minus y is equal to 4. And so if you want to think about adding these things, you should add it like polynomials. You would add x's to x's, y's to y's, numbers to numbers. So in this case here, we get an x plus an x, which gives us a 2x. We get a y plus a minus y, which gives us, well, 0 y's. There's no more y's left over. And then we get an 8 plus a 4, which gives us equal to 12. So this reduces us to the equation 2x is equal to 12. So then that x is equal to 6, which if you remember from a prior equation is in fact the correct answer. Well, that's nice. Let's see if we can do it another way and solve it for y. So another thing I noticed is that looking at these two equations, not only are the y's opposite signs, the x's are the same signs. They're both positive. So what if I do the first equation and then subtract off the second equation? Because then that would end up with being an x minus an x. If you just look at the coefficients, if you have positive x, if you have an x, you subtract the next from it, you'll have 0 x's. So in this case here, we get an x plus y is equal to 8, and then you're subtracting an x minus y is equal to 4. Sometimes I put a parenthesis here to indicate that we are in fact subtracting, and so that you can keep track of all your signs. So here we get an x minus x gives us 0 x's left over. Well, that's nice. And we have a y minus negative y, and that's where you have to be a little careful, is that you're subtracting a negative. So you have y minus negative y, which gives us a y plus a y. So we actually get a plus a 2y here. And then we have an 8 minus 4. So 8 minus 4 is 4. So this is really the equation. So this is really the equation. 2y is equal to 4. So y is equal to 2, which gives us our solution. Is the point 6, 2, which is what we found before. Now, this is called solving via elimination. So why is it called elimination? Well, if you want to look at this, is that we eliminated the y in that first equation. We added them because we noticed that the coefficients of the y add to 0. Over here, we subtracted the two equations because we noticed that if we subtract them, the coefficients and the x's go to 0. So this one we can think about is that we eliminated x. And in this one over here, we eliminated y. So that's the basic premise of elimination. So in general, what are the rules to elimination? And I'll be completely honest with you, it comes back to what we talked about very beginning of all these videos, is that it comes down to the addition and multiplicative properties of equality. So the first one is if you have two equations that are equal, so A is equal to B, that's equivalent to adding a number to both of them. In this case here, we're not just adding a number, we're adding a whole equation to both sides. And the second one is if you have a non-zero number, if you have A is equal to B, then if you multiply both sides by that non-zero number C, you have C times A is equal to C times B. And so the rules are, 1, you can add one equation to the other. So like what we did in the very first one is that we added the two equations together. The second one is that you can multiply one or both equations by a non-zero number. And so if you want to think about this, the first one is that when you add one equation to the other one, you're really just adding numbers to numbers here so that the two equations are still equivalent to each other. It doesn't change the properties of the solutions. And when you multiply one or both the equations by a non-zero number, it doesn't change what the solutions are. What this is saying up here with this theorem is that if you have like x plus y is equal to 2, then 2x plus 2y is equal to 4 is just an equivalent equation to that. So those are where these two come from. And then there's a third equation here, a third idea, is that you can actually swap the order of the equations. Like for instance, you know, in the previous example of the equations. So if you notice in the previous example, I had the equations numbered 1, 2. The swapping the order means, honestly, you could have done 2, 1. Like the order does not matter here. So the rules are is that you can add one equation to the other equation. You can multiply one or both of the equations by a non-zero number. And that's how the subtraction comes in. You multiply one of the equations by -1 and then add them, because subtraction is really adding the negative of a number. And then you can swap the order of the two equations. So let's really put this to the test. So let's solve this system here. I would like to point out that this one is not particularly nice to use via substitution, because the second you try to use substitution, you're going to deal with fractions all over the place. What's really nice about elimination is that you do not need to worry about fractions as much. So the first thing I'm going to do is I'm going to label these two equations. This is going to be equation 1 and that's going to be equation 2. The third condition of the rules means that we can swap them, which means that the order here, the labeling does not matter. And so what I'm going to do is go like, okay, taking a look at this, all the coefficients aren't super nice. But if I multiply the first equation by, let's say here, 3, and the second equation by 4, we notice that 3 times 4 is equal to 12. So then if we multiply the first one by 3, the second one by 4, the coefficient of x's is going to become 12. So what I'm going to do is eliminate x first by multiplying the first equation by 3. So that one is 3 times 1. This one will give us the equation 12x plus 9y is equal to 3. That's completely equivalent to the first equation there. And then 4 times the second equation, which will give us a 12x plus an 8y is equal to 8. That's equivalent to the second equation. So now we have this other system here involving these two equations. So now what I'm going to do is I look at this and go like, okay, great. Now I'm in the position where I have a 12x and a 12x in both equations. So if I consider this one 1 and this one 2, just swapping colors here, what I'm going to do is I'm going to subtract them. So I'm going to subtract the second equation from the first equation. So I have 12x plus 9y is equal to 3. And I'm going to subtract off a 12x plus an 8y is equal to 8. And see what we get. Well, the first thing I see here is 12 minus 12 gives us a 0x. 9y minus 8y gives us just a single y there. That's quite nice. And then 3 minus 8 gives us a negative 5. So then y is equal to minus 5. Great. That gave us a nice solution of the y coordinate of our point. So now we may ask, how do we get another solution? Well, you can use elimination again, and that is completely fine and up to you. But what I'm going to do is go back to our first equation here. So I have a 4x plus a 3y is equal to 1. So that's this equation here. This equation means that we also have that y is equal to minus 5 as the solution point. So this y is minus 5 means it also satisfies this first equation here. So plugging in using substitution, we have 4x plus 3 times a minus 5 is equal to 1. So 4x minus 15 is 1. 4x is equal to 16. So then x is equal to 4, which gives us our solution as 4 comma minus 5. Great. We did this with substitution. I just want to point out that this strategy here is often referred to as back solving, where in that you find a particular answer to one of the variables. In this case, we found y is negative 5. Then you go back to the original system and go like, okay, if y is negative 5, I'm going to use one of the original equations to figure out the x value, and that's called back solving. Lastly, you should get in the habit of checking your answer. So in this case here, we get 4 times 4 minus 3 times minus 5 is in fact 1, because that's 16 minus 15 is 1. So that one works. And then in the second equation here, we get 3 times 4 plus 2 times minus 5, which is equal to, well, that is 3 times 4 is 12 minus 2 times 5, which is 10, so that is a 2. So that works. So this is, in fact, our solution.